For this question, it states that Eric wants to go skiing tomorrow, but only if there are 4 inches or more of new snow. And according to the weather report, any amount of new snow between 2 inches and 6 inches is equally likely. The probability density curve for tomorrow's new snow depth is shown, and that's this thing here. This is a uniform probability density curve. Uniform because this height is always at 0.25, which is 25%, and it never changes as you go across the top. So for all of these possibilities down here, the bar up here goes up to 0.25, which means 25%. It also says the total area under this curve is 1, and that makes sense too. If these are all the possibilities, the total area under the curve would represent 100% of all of the outcomes. We are asked to find the probability that the new snow depth will be 4 inches or more tomorrow. What that means in this diagram is, well, instead of going all the way across and finding the area of this whole thing, which will be 1, they're saying start at 4, and 4 or more means go up until you get to the 6, and find the area of just that part of the rectangle. And this first part of the question says, well, can we just get a picture of what that looks like? And for me, it looks like this one here. This shaded part of the rectangle is going to be a number that corresponds to the probability of the event that we get 4 or more inches of snow. If we continue, it says, well, okay, that's the picture for it, but what's the actual probability that there's going to be 4 or more inches of snow? I really don't think we need a calculator for this, but just so we have something to look at, the way you would compute this is by, on your picture, you would say, well, the distance here is 1, 2, so that's the base of your rectangle. The height is going to be 0.25, so the product of those two numbers will give you this area, and that area is going to be the value of the probability, which is 2 times 0.25, which, it's obviously 0.5, but that's 50%. So here, I'm going to put in the probability 0.5 or 0.50. So that's everything for this problem. And the idea behind it is, if you have a probability density curve, the total area under the curve is going to be 1 because that's 100% of the data. But if you look at just a certain portion of it, like here we looked at half of the data, well, that corresponded to a probability of 50%.